Hello everyone, welcome to my channel. This channel is all about education, about different subjects that you probably don't know anything about, but if you did, they would enrich your life in various ways. And today is our 210th video on studying up on the reciprocal system of theory. And the reciprocal system of theory was originated by Dewey B. Larson back in the 20th century. He died back in 1990, but not before putting out many, many books and articles and talks about his reciprocal system, which he developed slowly over the course of 60 years. And the reciprocal system basically states that we live in a universe of motion. Not a universe of matter, not a universe of energy, but a universe of motion. Matter and energy are merely two different kinds of motion, as are all of the scientific quantities, mechanical quantities, such as speed, space over time. The car is moving 20 miles per hour. 20 miles of space in 1 hour of time. Acceleration. I dropped the ball off the balcony and it fell at 9.8 meters per second per second. That is 9.8 meters of space in 1 second squared. Space over time to the second power, acceleration. Then we also have force. Force is time over space to the second power. Energy, time over space. Matter is time to the third power over space to the third power. Pressure, time over space to the fourth power. And many, many other quantities. They're all are time over space. And that is because motion, according to Larson, is the relationship between space and time. And so space, motion is basically a fraction with space or time as the numerator and time or space as the denominator. But time or space can come in more than one dimension. This is what Larson refers to as coordinate space, X, Y, Z coordinates. But then there is also something called coordinate time, 3 or more dimensions of time. Then there is what Larson calls the clock time. Time is always getting later and later and later and later, but in no particular direction. This is what Larson calls a scalar motion, a motion that has a magnitude, but it has no particular direction. But we also have clock space. Space is always getting farther and farther and farther apart, and in no particular direction. This is the flow of space, and can be seen, has been seen by the Hubble telescope, noting that all of the distant galaxies are moving away from each other. And then time and space also have their discrete unit aspect, meaning that they come only in chunks. They do not come in continuous, they do not come continuously. They come in chunks. One chunk of space in one chunk of time, 1 over 1, equals the speed of light. So the speed of light is basically 1 in this system, and that sets it up to be the midpoint of this universe. So unlike Einstein, Einstein says that the speed of light is the max speed of the universe. In Larson's system, the speed of light is the midpoint of the universe. Half of the universe is actually moving faster than the speed of light. He calls this the cosmic sector. And half of the universe is moving slower than the speed of light. And this is the half that Einstein knew about, called the material sector. And we know quite a bit about the material sector because this is where we live, and this is where we have coordinate space and clock time. But in the cosmic sector, we know very, very little about the cosmic sector, but we can extrapolate because what we know about the material sector extrapolates over to the cosmic sector. All you have to do is reverse the roles of space and time. And so in the cosmic sector, we have coordinate time and clock space. And, there are certain caveats to that because we live and observe in the material sector. One of Larson's followers, Bruce Perrett, would say, we see space, but we do not see time. So whatever happens in time, we see it as it affects space. So we see the inverse of what's going on in time in space. An example of that is the white dwarf star. A white dwarf star is a star that is exploding in time. When a star is exploding in time, we don't see time. We see its equivalent in space. And so we see the inverse of an explosion, that being implosion, in space. And that appears as if it were a super dense and highly compact star, a white dwarf star. Okay, now many other things to say about that, but I've probably said it before in one of these earlier 209 videos. We are looking today at chapter 16 of Larson's book called Nothing But Motion. This book is primarily on atomic physics, and we're going over chapter 16 called Cosmic Atom Building. Now, in Larson's system, an atom is a combination of motions. Everything is motion. So an atom is a combination of motions. First, you have a photon. You actually have two photons that are kind of like the starting point for an atom. And a photon is a combination of two kinds of motions. In Larson's system, a photon is your combination of your translational motion. You have four kinds of motion. You have translational motion, you have vibrational motion, you have rotational motion, and you have rotational vibration. And you can have those motions in 1, 2, and sometimes 3 dimensions. But when you make up a photon, what you have is you have a translational motion, and then you have a vibrational motion in a perpendicular dimension. Okay? Perpendicular to the translational motion. When you combine those two motions, you get a sine wave. That is a simple harmonic motion, and that is the photon. Now, some of Larson's followers, in particular Dr. K.V.K. Nehru and Dr. Bruce Perrett, both insist that the photon is actually the result of a birotation. When you have two counter-rotating systems, then when you combine them, you also get a sine wave. And I believe that is the mathematician Leonard Euler's formulation from way back in the 18th century, called the epsilon function. And so there's a dispute as to how this photon comes about. But the main point for now is that the photon is a simple harmonic motion, and that's what you have to start with. Then once you have that simple harmonic motion, you can rotate it and that rotation creates a disk, and then when you have a disk, you can rotate that, and that becomes a sphere. So that is where the atom is formed from two rotating systems superimposed upon a photon. And then there is also a third motion, which would be like a spinning motion of that whole sphere, which is a one-dimensional rotation, which is optional. So the atom is a combination of three different kinds of rotations. And obviously, then a cosmic atom would also be a three different kinds of rotations superimposed on a photon, on a simple harmonic motion or a wave. But we don't necessarily see a cosmic atom in that same way, because when you're looking across the boundary, across a speed boundary or across a unit boundary, the rules invert. And so what you're seeing is not exactly what's happening. Both the rules invert, and there is something lost in the translation. Larson calls that the interregional ratio. And so even though the rules are the same, but inverted, rules of time and space are changed between the material and the cosmic sector, we don't see it that way, because our ability to see the cosmic sector is very limited, and because there's something lost in the translation. And then we also have to convert from space to its inverse in time, or vice versa. Really, we have to convert from time to its inverse or equivalent in space. Okay, we're going to take over here toward the end of this chapter, and the wheels have kind of come off on this chapter for me. I got lost not far through this, and I don't quite understand what he's talking about at this point. Even though I've read this chapter a number of different times, I've never quite got it. It's never quite kicked in. But that's not a reason to stop reading it, because if you continue to read it over and over again, eventually you will pile up little tidbits of understanding to the point where something eventually clicks. So we're going to keep going, and it starts right here. The new findings as to the nature of the transient particles and their production and decay do not negate the results of the vast amount of work that has been done toward determining the behavior characteristics of these particles. As stated earlier in this chapter, these theoretical findings are generally consistent not only with the actual experimental results, but also with the experimenters' ideas as to what the raw data, the various tracks, electrical measurements, counter readings, etc., signify with respect to the existence and behavior of the different transient particles. But what appears to be an immense amount of experimental data actually contributes very little toward an explanation of the nature of these particles and their place in the physical universe. It merely serves to define the problem. As expressed by Weisskopf in a review of the situation, quote, "The present theoretical activities are attempts to get something from almost nothing," end quote. Much of the information derived from observation is ambiguous, and some of it is definitely misleading. The experimentally established facts obviously have a bearing on the problem, but they are too limited in their scope to warn the investigators that they cannot be fitted into the pattern to which scientists are accustomed. For instance, in the world of ordinary matter, a particle mass less than that of the lightest isotope of hydrogen indicates that the particle belongs to the subatomic class. But when the effective masses of the transient particles, as determined by experiment, are interpreted according to this familiar pattern, they give a totally false account of the nature of these entities. Thus, while the determination of the particle masses adds to the total amount of factual information available, its practical effect is to lead the investigators away from the truth rather than toward it. The following statements by Weisskopf in his review indicate that he suspected that some such misinterpretation of the empirical data is responsible for the confusion that currently surrounds the project. Quote, "We are exploring unknown modes of behavior of matter under completely novel conditions. It is questionable whether our present understanding of high energy phenomena is commensurate to the intellectual effort directed at their interpretation. Availability of a general physical theory which enables us to deduce the nature and characteristics of the transient particles in full detail from theoretical premises, rather than having to depend on physical observation of a very limited scope, now opens the door to a complete understanding. The foregoing pages have provided an account of what the transient particles are, where the particles of natural origin, the cosmic rays, come from, what happens to them after they arrive, and how they are related to the transient particles produced in the particle accelerators. The aspects of these particles that have been so difficult to explain on the basis of conventional theory, their multiplicity, their extremely short lifetimes, the high speed and great energies of the natural particles, and so on, are automatically accounted for when their origin and general nature is understood. Another significant point is that on the basis of the new theoretical explanation, the cosmic rays have a definite and essential place in the mechanism of the universe. One of the serious weaknesses of conventional physical theory is that it is unable to find roles for a number of the recently discovered phenomena, such as cosmic rays, the quasars, the galactic recession, etc., that are commensurate with the magnitude of the phenomena, and is forced to treat them as products of exceptional or abnormal circumstances. In view of the wide extent of the phenomena in question and their far-reaching consequences, such characterization is clearly inappropriate. The theoretical finding that these are stages of the cosmic cycle through which all matter eventually passes now eliminates this inconsistency and identifies each of these phenomena with a significant phase of the normal activity of the universe. The existence of a hitherto unknown second half of the universe is the key to an understanding of all of these currently misinterpreted phenomena. And the most interesting feature of the cosmic rays is that they give us a fleeting glimpse of the entities of which the physical objects of that second half, the cosmic sector, are constructed. All right, that is the end of chapter 16 of Larson's book, Nothing But Motion. Chapter 17 starts out, chapter 17 is entitled Some Speculations. Okay, so he's just kind of getting into hypotheses and speculations here. We'll read the first couple paragraphs here. The reciprocal system of theory consists of the fundamental postulates, together with everything that is implicit in the postulates, that is, everything that can be legitimately derived from those postulates by logical and mathematical processes without introducing anything from any other source. It is the theory as thus defined that can claim to be a true and accurate representation of the observed physical universe, on the grounds specified in the earlier pages. The conclusions stated in this and related publications by the present author and others are the results of the efforts that have thus far been made to develop the consequences of the postulates in detail. However, the findings that have emerged from the early phases of this theoretical development call for some drastic modifications of the prevailing conceptions of the nature of some of the basic physical entities and phenomena. Such conceptual changes are not easily made, and the persistence of previous habits of thought makes it difficult not only for the readers of these works, but also for the investigators themselves to grasp the full implications of the new ideas when they first make their appearance. The existence of scalar motion in more than one dimension, which plays an important part in the subject matter of the two preceding chapters, is a good example. It is now clear that such motion is a necessary and unavoidable consequence of the basic postulates, and there is no inherent obstacle that would stand in the way of a complete and detailed understanding of its nature and effects. If it could be considered in isolation without interference from previously existing ideas and beliefs. But this is not humanly possible. The minds into which this idea enters are accustomed to thinking along very different lines, and inertia of thought is similar to inertia of matter in that it can be fully overcome only over a period of time. Okay, we will stop it off right there and resume tomorrow with the chapter 17 on some speculations on the book in the book Nothing But Motion. Thanks for tuning in and have a great day.